Hello, my name is Mark Gibson, and you're listening to the podcast version of the Teagasc Signpost Series, a weekly webinar that promotes and examines sustainability in Irish farming. Hello and good morning, and you're welcome to today's Signpost webinar. We hope you're keeping safe and well wherever you're joining us from today. So today we're going to be talking about a very innovative project called the FERTIMANURE project, and we know that the current dependency of EU agriculture on fossil-based mineral fertilizers has been identified as an extremely serious threat to food security across Europe and indeed the globe. However, the 1.4 billion tonnes of organic manures across Europe present a real opportunity for modern farming. The FERTIMANURE project is a project dedicated to develop strategies to efficiently recover minerals, nutrients, and other relevant products from animal manures. And the aim is to produce reliable and safe fertilizers that can compete in the European fertilizer market. And to discuss the FERTIMANURE project and European nutrient management strategies, we're delighted to be joined by Dr. Oscar Schoumans from Wageningen University in the Netherlands, and Dr. Nicolas Thevenin from RITTMO Agro Environment in France. Gentlemen, you're very welcome to this morning's webinar.
Thank you very much for the invitation.
And Pat, good morning to you. Pat, you're going to help us with questions later on. So maybe, Oscar, we could start with you and maybe give us a little introduction to the work that you're doing and your own background.
Thank you very much. I'm working as a scientist at Wageningen University in research in the field of nutrient management and environmental impacts already for 37 years. Main focus on programs like the Nitrate Directive, the Water Framework Directive, but also circular economy and the farm-to-fork strategy. Over the last 10 years, I started to focus more into nutrient recovering, valorization of bio-waste streams, biomass streams, to make products out of it that are safe and useful for practice on agricultural land. That's the main focus, and also that's the two projects I'm working on. Systemic, that's one of the projects on large-scale biomass valorization, and the FERTIMANURE projects, where we are looking at innovative new technologies to make new products out of biomass.
Okay, thanks, Oscar. That's a really interesting career you've had, and I know I can tell now we're going to have lots of interesting questions for you later on. And Nicolas, welcome. You're based in the Alsace region in France. Can you tell us a little bit about the work that you're doing and your own background?
Thank you. Hi, everybody. So I'm Nicolas. I'm working at RITTMO Agro Environment, which is a private research center working in the field of organic fertilization and environmental impact of fertilizers. For me, more precisely, I'm working in processes for biomass transformation into fertilizers since 14 years now. And first, I started with anaerobic digestion or composting or vermicomposting, and now the last 5 years, my research focuses more on pyrolysis process and of agricultural biomass and evaluation of agronomic and environmental impacts of biochar. So I'm also involved in different national and European projects in the thematic of returning waste of byproducts coming from agro-industry to the field, and always in the deployment of the circular economy.
Okay, great. Yeah, no, definitely a lot of interest in Ireland on the whole biochar area as well. So I think there'll be a lot of people interested in your part of the presentation. So Oscar, you're going to share your screen with us and start off the presentation. So Oscar, we'll hand over to you, and we will speak to you after the presentation.
So not only presentation of myself, also Kimo van Dijk, a colleague of mine at the Wageningen University and Research Center, and Arjan Prince from the Arjan Prince farm, where we are doing our pilot case in the Netherlands. And we're very happy that we have the opportunity to present here the last results coming out of this FERTIMANURE project. First, going into the what is the FERTIMANURE project about? We're dealing with an increasing global demand of mineral fertilizers. More people coming in the world. We need to the food amount needs to increase, so more mineral fertilizer has to be produced. On the other hand, resources are depleted. Phosphate rock mines are going to be reduced a couple of hundred years, and they are empty. On the other hand, not a lot of natural gas is being used to produce the nitrogen fertilizers. And what we see in Europe, there are regional nutrient imbalances between areas with intensive agriculture and areas extensive, and there is a need to redistribute and transport the right products to the right place. So we consider organic waste as a real opportunity to meet with the current goals of the bioeconomy, the circular economy, the farm to fork strategy, and all these sustainability goals. We have to go into a more transition to make use of all the products that we produce and reuse them. The current nutrient use efficiency is the use of fertilizers versus what is consumed is only 20 to 30%, so that's rather low. What are the goals of the FERTIMANURE project? To develop, integrate, test, validate innovative nutrient management strategies, to efficiently recover mineral nutrients and other relevant products from agronomic value like organic amendments and biostimulants. And we do that from animal manure because it's the main secondary resource of nutrients that we have. And we finally want to have reliable, safe, tailor-made fertilizers that can compete with the European fertilizer market. So that's the main goal. We have 5 pillars in the project. First of all, we are looking at nutrient recovery products and end products from different sites in Europe where they are produced. We are looking at the agronomic performance. What are the sustainability and safety aspects? Finally, of course, also the business models, and last but not least, the acceptance by the farm, so that we can prove the quality of the product, and also for the chemical industry and the policymakers to show that the products are safe. Today, in the project, we have 5 on-farm pilots running, and today we will discuss the Dutch one and the France one. I will present the Dutch one. So the Arnhem Prinsen farm, the Dutch pilot located in the eastern part of the Netherlands. Here you can see the family Prinsen on a package of milk of Friesland Campina, making themselves strong for a better climate. It says he's very sustainable minded. This farm, trying to become a front runner in making use of his own production process and going to the next level into nutrient cycle and nutrient management strategy. Here you can see his farm at the right side, 60 milk cows, 24 young stock, a couple of hectares of grassland, also for nature conservation and maize. And you can see over here, it's a digestion plant also. So he has anaerobic digestion with a nutrient recovery system. And why is he doing that? That is what's the main driver? And therefore, we first have to go to the Dutch nitrogen manure balance. And this is a figure over the last 5 years. The amount of nitrogen in million kilograms of nitrogen that is produced, the amount that can be applied on land in green. So finally, you got here the surplus. And over the last 5 years, it has been reduced. The surplus has been half of what it was in 2017. So we almost can close the manure balance. it's becoming to zero. Of course, we have still losses to the environment, but production becomes more in line what can be applied on agricultural land. However, recently, this year, 2022, EC said to the Dutch government, it's over with your derogation. We are phasing out derogation in a couple of years. So a reduction from 230 kilograms of nitrogen downwards to the 170 kilograms per hectare. Consequently, 60 million kilogram of nitrogen can't be placed anymore on land. So the surplus will increase with 60 million kilograms from 26 to 86 million kilogram of nitrogen as a surplus. So what we see now is that the total amount of required nitrogen for crop production is, at least in the Netherlands, much greater than the amount of nitrogen in the manure produced, and still we can apply less manure on land. So that makes that there is a need of nitrogen valorization out of manure as a substitute for mineral fertilizer. And that means that the nitrate directive should change in such a way that products which are capable and as good as mineral fertilizers should be accepted as mineral fertilizers. It's a discussion now with the EC, the renewal criteria to be implemented. That is very important that becomes real practice next year. So this is the situation, and this farmer was already looking into the options to valorize the valorization of nitrogen and his farm itself. So he has his own aerobic digestion, and the main reason to do that was because of the coal of Friesland Campina. Friesland Campina, the dairy milk producent in the Netherlands, want to have a lower CO2 footprint. So that's why many dairy farms in the Netherlands are making the step to implement anaerobic digestion. Here you can see what the feedstock is, mainly slurry, some farmyard manure. In the past, some sugar beets, that's not allowed anymore, some feed residues, and total input of about 2,000 tons of products. And the quality of the diet you can see here on the right side. In terms of nutrients and dry matter and organic matter content. This is the process scheme of what he has been doing on his farm on digestion and nutrient recovery. So we have the production of cattle manure. Cattle manure is going to the digester to make a biogas out of it. And the biogas is used in a central heating power to produce energy and also heat that can be used at his own farm as a substitute from energy coming from the grid and heat coming from the grid. He's producing it by himself, and also for the nutrient recovery in his plant also. So that's an important step. Thereafter, the digestate is being separated in a solid and liquid phase. We are trying to do a sort of biological acidification to release a part of the phosphate out of the solid fraction of the manure, because there is also a phosphate surplus in the Netherlands. In that case, more phosphate will come into the liquid fraction, and there we try to extract it to get an organic P rich fertilizer. And the solid fraction will become less amount of phosphate in it, so you can apply more of the organic material on land, because we have also a limit on the phosphate application on agricultural land. So by reducing the amount of phosphate in the digestate and set it separate, we are available to apply more on the land. The liquid fraction contains a lot of nitrogen and potassium, and that part is going to a stripper to get the ammonia to the air, and then it is gone through an sulfuric sulfur acid to make ammonium sulfate out of it. And what's left over is an organic mineral potassium fertilizer. So in this way, we are separating the cattle manure products in different type of products: organic matter with a rather low P content, an organic P-rich product, a liquid product with a lower amount of nitrogen and a lot of potassium, and a real rich ammonia product. So a separation of the main nutrients out of the cattle manure. So the end stripping installation is operational at that farm. It's not always in use. Only when he needs the fertilizers, he's going to use it, and also taking into account the energy cost of his plant itself. The stripper operates in batches, so we can stop it easily, can be easily controlled. It works at a temperature of 40 degrees. That's not that high, but the pH is 7.8, and then it's possible to extract already a sufficient amount of nitrogen that he needs above the 170 kilogram of nitrogen, which he can already apply by the manure itself on his land. The main challenges are to achieve a stable and optimal nitrogen concentration of the ammonium sulfate in the batches, and also to regulate the pH of the product so that he can apply it at a pH of max 5.5 due to legislations regarding application technology. It's working, he's glad with it, so it's for him it's a big step forward. Here you can see the mass balance. So for the last 2 years, what's going in digestate, he needs some sulfuric acid for the making of ammonium sulfate. And then here you can see the amounts of produced bio-based fertilizers, we call them. So the soil conditioner, the wet orage pea sludge, not that much, and the liquid potassium fertilizer, ammonium sulfate, and totally in balance. So the liquid potassium fertilizer is still the main part, but can easily be applied on the land because it doesn't have that much nitrogen anymore. So you don't have to transport it, to export it from the farm. You can see the nutrient content of ammonium sulfate over time, producing from 2021 up to recently September 2021. So about 5.5 gram per kilogram. That's 5.5% of nitrogen in this product, and the average is about 5.5%. There is sometimes better conditions, higher recovery, but most of the case it's between 50 and 60 gram per kilogram, 5 or 6%. This is a more difficult picture, but I do want to present it because this is what the farmer tries to do now. He needs 140 kilograms of nitrogen on his maize land. This is just a scenario for maize land. A P limit of 30.6 kilogram P, that's about 70 kilogram P2O5. He wants to have 2,000 kilogram or organic matter on his land, and the sulfur not above 10 kilograms of sulfur per hectare. And now he has his He can use only mineral fertilizers. He has also the bio-based fertilizers. He has his manure types, which can be the digestate or the cattle slurry itself. So he has different options to combine to meet with the end sources on his land. So he needs 140. And we did 2 scenarios, just one based on the recommendation. So I want to meet as much as possible with the conditions over here. And then you can see if you only apply mineral fertilizers, then the price will be rather high, about 600 euro per hectare. If you're going to be used bio-based fertilizers and mineral fertilizers, the substitution is less on maize land, not that much. Even if you going to use manure together with mineral fertilizers, then the bio-based fertilizers are skipped, but you can have a lower price per hectare. But finally, if you can use his cattle slurry together with the bio-based fertilizers, and then less mineral fertilizers are used, he has the best price if you look only at the recommendations over here. If you do it together, not only looking at the recommendations, but also with the price setting, then other combinations are possible in order with the required nitrogen. And you can see that in both cases, using his manure, the bio-based fertilizers and the mineral fertilizers are much better in the case than using only mineral fertilizers and the bio-based fertilizer itself. So we can make the optimum. And if you look at, for those conditions, what is the amount of P applied, we are really exactly at the level that is needed. And also for sulfur, we are exactly at the level that is required. Only the organic matter, it's clear that if you only give mineral fertilizers, you don't get your 2000 kilogram of organic matter. But in this case, even using the cattle slurry, the bio-based fertilizer, and a little bit of mineral fertilizers, you can even meet with the organic matter amount used for your land. So a real possibility to make tailor-made fertilizers out of your mineral fertilizers if you are going to do digestion together with mineral stripping into ammonium sulfide or other products. So we are looking at possibilities to make tailor-made fertilizers and to reduce the cost for the farmers to buy mineral fertilizers and meeting the requirements of the crop. Coming to my last slides, the lessons learned. This dairy farm can become much more self-supporting. The biogas production gives a lower CO2 footprint, and he can use his own energy and heat production. Now with the high prices, it's only benefit. And he has the option to sell the energy to the grid. He's producing his own nitrogen mineral fertilizers. He has a lower CO2 footprint also because of that, because there's no need to buy mineral fertilizers, mineral nitrogen fertilizers, which are produced with a high natural gas amount to produce the ammonium products. And he becomes less independent of the prices of the mineral fertilizers on the market, which are increasing now due to the war in Ukraine. He can do a better closure of the farm nutrient balance, options to produce tailor-made fertilizers for maize land, and he can even do that for each cut of grassland. So the right blending of ammonium sulfate, liquid potassium fertilizer, soil conditioner, and the wet pea slurry. However, it's another farm business plan. and additional farm activities. He is doing it itself, but there are possibilities to do the outsourcing, for instance, for the nitrogen recovery thing. But in fact, yeah, it's a transition that you have to undergo. Both biogas production and both the biogas business case and the nitrogen recovery and reuse business case are separately positive, even at normal energy prices. So he earns money. Agronomical point of view, there are no significant differences compared to mineral fertilizers. That's another work packages where it is tested. And the environmental impact, yeah, that's difficult to determine the differences in real farm practices. We can do a lot of experiments in the laboratory. There it seems to be okay. What is important is the 4R stewardship. So the right amount on the right place, on the right time, in the right form, can reduce always, in any case, the environmental impact. And finally, there is one barrier, and that's the nitrates directive at this moment, because all nitrogen products derived from manure are still manure and has to account for the 170 kilograms of nitrogen. So the recovery nitrogen for manure, the renewal criteria that needs to be implemented as soon as possible. That's important for the circular economy and also for the farm whole business case, and there are no economical and environmental aspects that can be concerned. Thank you very much for your attention.
Thank you, Oscar. Really, really interesting presentation there. So I'm sure I can see the questions already coming through from your presentation. So if you could just stop sharing for us, Oscar, and Nicolas is going to share his slides with us then. So Nicolas, we have about 10 to 15 minutes or so.
Okay, so I will present now pilots coming from France, and you will see there are a little difference from Oscar pilot's scale. Indeed, in France, we developed pilots, but mobile pilots. We are not at industrial scale, but objective is to use these pilots, so pyrolysis and nitrogen stripping, to move from farm to farms and to demonstrate to farmers and to produce data and collect data about byproducts, composition, and characterization. So in details, at the beginning of the project, to focus on poultry manure, and with these dry products, we use pyrolysis process to produce biochar. Here, it's a photography of our pilots. And on the second step, we are more focusing on anaerobic digestion, and we pyrolysis solid digestates here to produce biochar, and we also try to work on liquid phase using nitrogen stripping to also produce ammonium sulfate and liquid phase with potassium. So here you have just photography of how we move our pilots using simple trucks to farms. Just to present, we test these pilots on farms to the east of France, since it's my regions, but also in west of France, because in these regions we have the same problem as in the Netherlands concerning nitrogen surplus. Here, first I will start to present you results from pyrolysis experimentation. So we have the same steps as whole pyrolysis plants. So first we need to grind our products, because we have screw into our oven, and we are limited to 25 millimeters. So we need to grind our products and also to dry which is a long step and expensive step if we are considering energy needed. But in our case, we use the sun, so no energy consumption. After we powderize products and we obtain biochar, we powderize at 700 degrees concerning poultry manure, and we reduce the temperature to 550 degrees for solid digestate. We are between 25 to 30 minutes of residence times, and pyrolysis gases were bound in a flare, and we obtain a temperature between 700 to 850 degrees. Here I present and I compare composition of raw manure. Here is poultry manure in blue to biochar obtained from poultry manure in orange. So concerning dry matter organometer, we don't see so much difference, but as we reduce organic matter, we are more concentrating in carbon, and most of carbon is on organic parts. Most interesting could be, the nutrients contents, more especially concerning phosphorus and potassium, as we clearly concentrate these elements on fresh matter, on biochar, which could be very interesting to test potential of biochar concerning phosphorus fertilization. And this table, I compare solid digestate, so the last result we obtained, and biochar coming from solid digestate. We also obtain the same tendency with concentration of elements of nutrients on biochar. And just 2 words to show you the yield of production. The treatment of 1 ton of poultry manure results in a production of 267 kilograms of biochar, and for 1 ton of solid digestate, we obtain 320 kilograms of biochar. Now, I will present you the nitrogen stripping pilots. We also do some experimentation in France and in different frames, and also in anaerobic digestion plants here. As Oscar perfectly explained, we use the same process at the industrial scale, but we had a heater to heat liquid at 60 degrees to optimize ammonium volatilization, and we also increase the pH to 10, also to obtain a better yield for NH4 extraction. We have a different ratio. Here we are at 200 ratio air to liquid. And also we only produce ammonium sulfate with 50% concentrate. So we obtain a yield of nitrogen extraction ammonia extraction up to 85% of initial ammonium input. But in our pilots, the process could be carried out until the desired NH4 concentration is reached with a recirculation of treated digestate for restrip again. Here I present a table where I compare liquid digestate here to effluents, so ammonium sulfate produced, and liquid fertilizer we obtain after. We are in our ammonium sulfate solution a concentration of total nitrogen between 4 to 6%, which all part is on ammonium form. We don't have potassium and we don't have phosphorus for this. Concerning the yield, we obtain the mass balance survey. We obtain the same result as Oscar. We are between 8 to 9% of total inputs, which is on ammonium sulfate form. And all the digestate, the amount of initial digestate is also in liquid fertilizer. As a conclusion here for our pilots, in France, we're more focused to produce data and to give information of byproducts characterization to add this data to perform and to produce business cases. So concerning nitrogen stripping, we need to test and to on other farms and other liquid digestate to evaluate if the process and how works the process, and also to demonstrate to farmers that it's not so difficult and which to involve stakeholders to perform this this process on their farms. And concerning pyrolysis process, it's the same way. We need to produce data also to test biochar produced on the fields, also on pod trials to evaluate its agronomic performance. And a big point is also to estimate the energy balance. In fact, we need to evaluate the potential energy from it generated. We will focus on industrial examples for this. Yes, because if we consider literature review, pyrolysis process don't need so much energy, and energy produced could be used directly on the pyrolysis process. But the big point is it's for biomass drying, which need important energy content. And also for biochar, it's organic amendment with high stability, but there is some interesting results concerning the bioavailability of biochar. We already done some pod trials with interesting results in which P of biochar is bioavailable, but we need to confirm this tendency now. And thank you, everybody. Thank you for your attention.
Thank you very much, Nicolas. Really great to see the practical examples, and particularly Brittany, which is not that dissimilar to some parts of Ireland as well. But I do know that there are issues there with nutrient balances in that area due to historic reasons. So thank you both for keeping on time. So we've lots of time for questions now. So we have some questions coming in so far, but just maybe question to start off, Oscar. You talked a lot about the ammonium sulfate as the end product from the process, and I'm just wondering, has there been work done to look at the greenhouse gas emissions associated with ammonium sulfate, or how safe is that from a climate change perspective?
Good question. It's safe enough if you directly inject it also into the soil. That's important. Like you always has to do with dairy slurry, just injection in the soil, then it is really limited. You can control it. It's as good as other liquid fertilizers. Ammonium sulfate is also a product on the market itself as fertilizer. So it's a direct substitute of that.
Okay, very good. Yeah, because I know that in Ireland there's a lot of emphasis on the use of protected urea as a means of reducing our emissions and to the moving away from the calcium ammonium nitrate that's being used. So just interested in that the actual overall impact from a greenhouse gas emissions. I imagine there'd be some people looking at the webinar this morning who mightn't be as close to this as we would be, but maybe saying, are we moving away from nature to a degree here, where we're moving down the route of doing a lot of processing on fertilizer organic manures? What would you say to people who would be that view, saying, well, should we not be looking for more nature-based types of solutions to these problems?
That has to deal with the type of farming that you are doing. You can become extensive, or you can become intensive. And if you become intensive, then you need to do something with your surplus of nutrients that you are producing. And the best way is to recover it and you reuse it. We didn't want to do something with the how do you say, changing the agricultural system. We want to do it by just technical innovations as a step to close the nutrient loop. Yeah, that's a decision. You can also try to change the way you're setting up your agriculture,
but
your diet, everything in order to get a better closure of your. But that's another discussion.
It is entirely, I agree with you. And I mean, look, you're presented with the challenge, and you've very innovatively come up with solutions here to address those issues. Maybe, Pat, we should go to some of the questions, because there's some very, very good questions coming through from the viewers.
Yeah, and I think there's a number of questions where people are trying to get their heads around that issue of whether we're responding to a regulation in what you're doing, and maybe I suppose what people are trying to do is put it in an Irish context and see with a very different system where it fits in. I suppose a couple of specific questions. One is, why is sugar beet no longer allowed in digesters?
Okay, then you are increasing the amount of nutrients on your farm by importing sugar beets with nutrients. It increased the biogas production, but Friesland Campina said, no, we want to close the loop at the farm, so don't include other products anymore into your farm system. So become a mono-digestion approach.
There's a question in relation to the capital investment at farm level that would be required for this. And I suppose an additional question about the ability or the preference for having this on individual farms as opposed to being maybe a cooperative approach with a number of farmers getting together to give them scale.
Yeah. Both. Okay. The first question was about investments cost, I think you said.
Yes.
That's about, you can say 100,000, 120, 125,000 for the digester for this farm scale. Okay. And also similar amount, 125, 150,000 for the stripping installation. Together with pumps and everything, we are calculating now for 380,000. So digestion and nutrient recovery, euro for the farm.
Okay, and I suppose a related question on that is, and I think you alluded to it towards the end of your presentation, is the effort of the farmer and the workload that's involved in the management of this almost a separate enterprise, and the potential addition of workload and distraction from the core job of minding the cows. So
exactly. You're becoming more technical, I think, but that's why I use the word outsourcing. There is a possibility that engineers are going to help you, or separate units, or
I presume further automation once you get this thing running.
Yeah, really. That's
just a comment that came early on, which thanks you for a fantastic presentation. Just in case I forget to add in that afterwards.
You're welcome.
There's a question there. I think in your slides you showed a concentration of some of the nutrients in the biochar versus the original manures, but the nitrogen didn't concentrate. So there's questions about what form is that nitrogen being lost in? Is it benign, or is it environmentally problematic? If you understand my question.
Yeah, I understand your question. So we already discussed about it. Yes, nitrogen is on organic form, but it's not bioavailable. So it's blocked into biochar particles. So yes, you're right. Organic nitrogen on biochar is stable nitrogen, which is blocked on the soil. That's not available for plants and for soil activities.
But the portion that you lose in the process of pyrolysis, the amount of nitrogen that you're using, what form is that nitrogen that's being lost in the translation process?
During pyrolysis, so nitrogen loss is gaseous form. So it's more, if you have ammonium nitrogen, it's lost into ammoniac forms. So it go to gases. In our case, we burn it, so we produce some oxide, nitrous oxide.
Okay, so it is potentially problematic.
Yes, if we have a lot of nitrogen in our inputs. That's why we try it, but poultry manure is not the good manure to pyrolyze because of too much nitrogen and gases with a lot of nitrous oxide.
Okay.
We have a question, Pat, here on the level of supports that the farmers were getting from Campina or for the government to establish the anaerobic digestion, or what level of interest does the corporate the industry have in terms of these types of solutions succeeding?
That's quite interesting question. What we see over the last 5 years, 6 years, that Friesland Campina is really supporting farmers who are going to do, including anaerobic digestion and also nitrogen stripping. They call it the Jumpstart project, to get farmers on board to make these steps. They get a higher price for the milk. So that's the way they try to support them. Because Friesland Campina wants to have a green label. We have a less CO2 footprint, and we are recovering and using and reusing all our nutrients that we are using.
So they see that as strategically important for them.
And in the Netherlands we have a system that you have green certificates for your producing of biogas. So there is a sort of income over there. And for large scale plants who doing the real manure treatment and export of the surplus, they have also a gate fee for the manure, which they have to treat in order to send it to Germany or whatsoever. So there are different types of financial constructions making this a positive business case. But in the end, all the products should be as good as the need of the farmers. They should be. They should have a high nitrogen fertilizer replacement value. They should have available phosphorus in terms of soluble phosphorus for the plants. So it's not only getting it out or whatsoever, it's also making the right products and that the release of the nutrients are in time over the year. And that is still, to my opinion, the main challenge. We want to introduce the circular economy. And that means that we have to look in making the right products also.
Mm-hmm. And reducing those losses to the environment at the same time. Absolutely.
That's the whole policy about reducing the environmental impacts. Yeah.
There's a kind of a complex question arising out of whether one of the impacts of what you're doing is effectively trying to replace some of the animals that are going to be coming out of your system with plant-based production, which then forms, as well as the nutrient aspects, but also becomes a separate enterprise for the farmer in terms of the production of potential production of energy. And do you see that as a minor part of the equation, this kind of shift into another enterprise, or is it potentially a major part of what you're trying to achieve?
I think to the future, upcoming 10, 20 years, this will increase, especially by the young farmers. They are well aware of what's needed and the goals that we have to achieve. In the Netherlands, we still have a lot of old farmers now and no follow-up. They will disappear. The rights of production will go to other farmers. They will become bigger. So the possibilities of the larger parts, farms, and also the younger farms coming up, will give a change in how they are looking into the farming system itself, I'm sure.
Yeah, and I suppose another question here in relation to the feed-in tariffs that are potentially there. I suppose if you're talking about energy at the moment, with the prices of where it's at, it won't need feed-in tariffs. But if energy prices go back down again, is development in this space dependent on feed-in tariffs being applied?
Yeah, yes, it will, but it will shift. What we hope for is that also farmers can be paid, or treatment industries can be paid for the CO2 credits. So if they do it in the right way, you should be paid for those credits. That is stimulating. Then you will go not for just making biogas or whatsoever, do it in such a way that you get CO2 credits for it, or even methane or ammonia credits by reducing ammonia losses. So we have to come to a system where protecting the environment is going to be paid instead of just producing products. It should become a combination.
So there's a question here: why are the commissions so slow to allow renewal? And I think is it lack of understanding, or because it's too hard to change the systems? Now, I'm sure what it's meant there is the designation of the product of what you're doing being chemical rather than being organic.
Yeah, this part, making nitrogen-rich products, mineral products, is chemical. It's not a way of organic production. Why is the Commission so slow? I'm not sure. There is maybe a second agenda about this, because the countries who are doing this are countries with high intensive farming system, and the Commission don't like those way of producing products. They want to go to a more extensive way, and they see if we allow this, then there will be more increasing possibilities to grow by these large farms and things like that. That's, to my opinion, the agenda behind it. In fact, there is a real barrier, and that is they don't want to break open the nitrate directive. If you break open the nitrate directive, everybody can change what they want to change. It has to go to 27 countries and things like that. Then we don't have a nitrate directive anymore. So it will be done by a sort of derogation, and each country has to ask for a derogation of this renewal criteria. And if that's the case, then they're working now that derogation will be possible. And that takes time, unfortunately. The link to organic, I found interesting. Within FERTIMANURE, we have a discussion nowadays. On one hand, the EC says we have to increase organic farming with 25%.
Mm.
And the other point is we have to increase our circular economy.
Mhm.
But the products of circular economy, like ammonium sulfate, is not accepted as mineral products in organic farming. So one way go to the organic farming, and other way circular economy increasing. It doesn't fit with each other because the philosophies are different. So that could be an important option we want to discuss also with the people of organic farming. Yeah, how can we break this part, because we need each other. We need to come to the circular economy, and we need to substitute the mineral fertilizer and organic products. We have to accept both new ways of producing fertilizers.
There's a kind of a follow-on to what you talked about in relation to not necessarily the organic, but the I suppose the balance of the production system, where I suppose in Ireland we've very much grass-based on grass, and I suppose one of the questions, and maybe it's particularly to Nicolas because their system is probably more similar to ours, is this development going to push farmers to a more indoor year-round indoor production system potentially than the outdoor system? In that, I suppose, in that you're looking at the production of manures into a plant, and I suppose the interest in Ireland is most dairy farmers, for instance, will be have their cows out from February till November.
Yeah.
Which means that there's a very small amount of nutrient produced in that housing period. So do you move to a system, or is there a temptation to move to a system that's more indoor to keep producing the manures and have that year-round production?
No, I'm not sure it's a philosophy in France to have more indoor animals, but must to mix biomass into anaerobic digester plants. For example, we in France, sorry, policy it's most in favor to collect, for example, pig slurry or cow slurry, and to mix with biowaste coming from agro industry or coming from each of us, and it's more on this way to not develop indoor animals, but add different biomass into the same anaerobic digestion plant. We have the opportunity to do it because we have a lot of biowaste separate collection, and so I think like in our European country. But it's not so a problem. And also in France, we are allowed to add to the limit of 15% of crops and energetic crops into our anaerobic digester plant.
Okay.
So,
okay, Oscar and Nicolas, I'm afraid we have run out of time this morning. Where has that hour gone? Obviously, a really interesting subject because of the number of questions that we're getting through, and I think this is an area that we're definitely going to have to be looking at in Ireland. I know there's a lot of discussion around anaerobic digestion as well, and potentially centralized facilities there for processing manures, but definitely it is a very, very topical area. So thank you so much for your excellent presentations. They will be available on our website afterwards. And Pat, thanks very much for helping with the questions this morning. And I want to say thank you to Yvonne Maher and Andy Boland and our production team. Next week, we have a very special presenter joining us next week, Mary Donnelly, who is the chairperson of the Climate Change Advisory Council, is going to join us, and we'll be speaking about the challenges and opportunities of the green transition. So Mary, very, very important role that she plays as chairperson of the Climate Change Advisory Council, which is effectively advising the government in Ireland on climate change action over the next number of years. So we do look forward to welcoming Mary next week, and hope you can join us. In the meantime, have a good week, and And I hope you all get to enjoy the Late Late Toy Show again tonight. It's hard to believe it's a year since we had this discussion. So enjoy the weekend, and thanks again for joining us. Okay.
I'm sure our presenters haven't a clue what you're talking about when you're
Absolutely not. It's a very Irish thing, Oscar and Nicolas, an Irish tradition around Christmas time. So we'll send you the links.
Okay. Thank
Take
you
care.
very much.
Bye-bye.
Thank you very much.
You've been listening to the podcast version of the Teagasc Signpost Series, the weekly webinar that promotes and examines sustainability in Irish farming. Don't forget to join us live every Friday morning for our latest webinar. For more, visit teagasc.ie. And you can also rate, review, and subscribe to the Signpost Series on Apple Podcasts, Spotify, or wherever you get your podcasts from. I'm Mark Gibson, and thanks for listening.